be teaching you about fractions. What are fractions though? Well, fractions show you equal parts of a whole. These parts have to be equal, all right? As you can see here, all the parts are equal. Now, how do we make a fraction? Well, a fraction is really parts, and then you draw this horizontal line, so over total parts. Say here we have shaded parts and total parts. In these diagrams, pictures, drawings, shapes, the shaded means white or off-white. So how many shaded parts are there in this diagram? 1. How many total parts are in this diagram? 1, 2. So that would be 1 over 2, written like this. 1 with a horizontal line over the 2. Now what about this? So there's how many shaded parts? How many white parts? 1. So that's 1 shaded parts. And then there's 1, 2, and 3 because we counted the shaded part for the total number of parts. So 3 total parts. That would be 1 over 3. Which you can also read as 1/3. 1 over 2 can be read as 1/2. And for this diagram, we have 1 shaded part again, and then 4 total parts. That would be 1 over 4 or 1/4. This one over here is, well, has a lot of parts, but there's still only 1 shaded part. So that's 1 over 1, 2, 3, 4, 5, 6, 7, 8 total parts. So that would be 1 over 8 or 1/8. So by this point you may have figured it out. It's not bad if you don't figure it out, but you may have figured out why we need equal parts. Think of 1/2. Say you're sharing a slice of pizza with your friend. A pizza is kind of a triangle. That's not the best triangle you can draw, but we don't have a ruler. If you're trying to draw very good shapes, diagrams, mathematically correct ones, you should probably use a ruler and many other mathematical tools for drawing. And your friend, if he gives you this much, he give you around half. He or she. That'd be fine. But if the parts weren't equal, say this was a slice of pizza, and they gave you 1 part over 2 parts, and they only gave you this much, you should probably stop being friends with them, unless you don't like pizza. But that's not equal, which is why when you use fractions, you have to use equal parts of one whole. Since if the parts aren't equal, then technically anything could be 1/2 of a whole. Now let's do some practice problems. Write the fraction of the shaded part. We have that circle up there. How many shaded parts are there? 1. So 1 shaded parts. And how many total parts are there? Remember to count the shaded part with the total parts. 1, 2, 3, 4, 5, 6, 7. 7 total parts. So since it's parts over total parts, for a fraction, then it'd be 1 over 7 for this fraction, or 1/7. What about question number 2? Well, we still have only one shaded part. But how many total parts do we have this time? Well, there's 1, 2, 3, 4, 5, 6, 7, 8 non-shaded parts, but there's also one shaded part that we must count. Remember to also include the shaded parts. So that's 9 total parts. And the fraction would be 1 over 9, or 1/9. There's also question 3 and question 4. Now there's one shaded part and 1, 2, 3, 4, 5 total parts. So the fraction would be parts over total, which is 1 over 5, or 1/5. What about here? Well, we still have one shaded part. And 1, 2, 3, 4, 5. Oh, it's 5 total parts again. The fraction is still 1/5, or 1 over 5. Even though these two diagrams are different, they're still representing the same part to whole, even though the parts and the whole is different. So that's basic fractions. Now, apart from fractions that only have one part out of a total, there are many other fractions, and sometimes there's more than one part. In fact, I'm going to tell you this, but the number on top is called the numerator. The number on top of a fraction. And the one on the bottom is called the denominator. You'll be learning this many more times. Anyhow, so in this picture we have 2 shaded parts. So it'd be 2 for shaded parts. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9 total parts. The fraction here, instead of 1 over 9, would be 2 over 9, or 2/9. Now that we've got that example down, let's do some practice problems. Write the fraction for the shaded part. So how many shaded parts are there? Well, there's 1, 2, 3 shaded parts. And there's 1, 2, 3, 4, 5, 6, 7 total parts. The fraction would be shaded parts over total parts. 3 over 7. Remember to count the shaded parts in the total parts. Because if you don't count the shaded parts, then you're not counting all the parts, which means that you're not counting the total parts. Here we have 1, 2, 3, 4, 5, 6 shaded parts, and 1, 2, 3, 4, 5, 6, 7, 8 total parts. Now the fraction here would be shaded parts over total parts, which is 6 over 8. This fraction is not in its simplest form, but you will be learning simplest form, not in grade 2. Now here's the last two fractions. How many shaded parts do we have? So we have 1, 2 shaded parts, and 1, 2, 3 total parts. So we just get 2 over 3, shaded parts over total parts. And here we have 1, 2, 3, 4, 5 shaded parts, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total parts. So that'd be 5 over 12. Now you can do non-shaded parts. For not shaded parts, you would just count the parts that aren't shaded. And that would be 7 parts. And you have 7 over the total number of parts, which is 12. But right now we're counting shaded parts, so it's 5 over 12. Oh yes, and also, when you do tests, quizzes, and things like that, or maybe even projects, a lot of the times in higher grades, they will give you a number mark and maybe a letter mark with it. Sometimes people use letter marks, sometimes they use number marks. Personally, I prefer number marks because they're more accurate, but a lot of the times they will have the total number of points that you could have scored, and then the number of points that you did score. Which is why there's the, 100 out of 100 entire thing. Alright, so that's it for fractions with numerators that aren't 1. Numerator is the number on top. Now, you can take a break whenever you want, just remember that. And we can move on to the next section. Interestingly enough, our next section, section 3, is a problem-solving strategy. Today's strategy will be drawing a picture. Now, I'm just going to tell you this. In subjects that aren't geometry, which is a study of shapes, you will draw less and less pictures as you move up the grades. Especially for things such as fractions, multiplication, division, addition, subtraction, you will be drawing less and less pictures. But since, well, this is a grade 2 math class, we're still drawing pictures. Draw a picture to solve. Show your work. Horatio is making a spinner for a game. He draws a circle with 3 equal parts. Then, he colors 1 part orange. What fraction of the spinner is not orange? Okay, guys, I know that this isn't the perfect circle, and this is probably not 3 completely equal parts, but because I don't have a compass, which is a circle drawing tool, I don't have a protractor to measure out each part, and I don't have a ruler, well, this is what we have. This is why it is important to draw mathematical diagrams with the proper tools if you want them to look, well, correct and accurate. So let's color 1 part orange, or just let's color 1 part. It doesn't have to be orange, because a lot of the kids that I knew back in the day didn't bring colored pencils to school, or colored really anything. So we have, what fraction of the spinner is not orange? Okay, so that's 1, 2, because the shaded part is orange. So that'd be 2 over how many parts are there in total? 3, because it says right in the question. So that'd be 2 over 3, or 2/3 of the spinner that isn't orange. So 2/3 of Horatio's spinner is not orange. Okay, let's move on to the next question. So here's our next question. Lara and her sister Felicity made a quiche and cut it into 10 equal slices. They sprinkled chili on 6 slices. Then they put peppers on the last 4 slices. Lara does not like peppers. What fraction of the quiche can she eat? So, I'm assuming that they don't mean as chili being peppers, even though chili usually does come from peppers, unless you're talking about that type of chili. Like, you know, the one with the beans? Then you might not have a lot of pepper in that. Anyways, so we know that on the 10 slices, okay, I'm going to try to draw this as accurate as possible, and that didn't really work, but we don't have a compass, we don't have a protractor, and we don't have a ruler, so. There's 4 slices that have peppers, and Lara doesn't like them. So there's 1, 2, 3, 4, 5, 6 slices left. So that's 6 over 10 slices. 6 slices over 10 slices. Which means that Lara can eat 6/10 of the quiche. So that's our problem solving section done. You can take a break whenever you want. So what happens when the number of shaded parts and the total number of parts is the same? Well, that's what we call fractions that are equal to 1. So you can write a fraction for the whole. Since there's 8 shaded parts and there's 8 equal parts, then that means that the top number would be 8 and the bottom number would be 8. And when the top number and bottom number are the same, then the fraction is 1. It is equal to 1. Now here we're going to count the parts in each whole, then write the fraction for the whole. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total parts. So shaded parts over total parts is 10 over 10. The numbers are the same. 10 over 10 is equal to 1. Here, there's 1, 2, 3, 4 shaded parts, and 1, 2, 3, 4 total parts. 4 over 4. The top number and the bottom number are the same, which means that the fraction is equal to 1. Here, there's a hexagon divided into 1, 2, 3, 4, 5, 6 shaded parts. And there's 1, 2, 3, 4, 5, 6 total parts. 6 shaded parts over 6 total parts. The top number and bottom number, which is the numerator and denominator, they're the same, which means that this fraction is equal to 1. Question number 4, there's 1, 2, 3, 4, 5, 6, 7 total parts. And there's 1, 2, 3, 4, 5, 6, 7 shaded parts. Which means, since 7 is equal to 7, 7 over 7, or 7/7, is equal to 1. Okay. Fractions, just like any other type of number, well, anything else in math really, can be compared, which is what the next section is about. Now in grade 2, you will be comparing fractions by looking at pictures of the fractions, or diagrams, whatever you want to call them, images. But as you go further into math, you will learn how to not use pictures and still be able to compare your fractions. But since you guys are still in grade 2, we're just going to be using pictures. Compare the shaded parts. Which fraction is greater? So we look at these two parts, and it seems that the fraction on the left is bigger. Okay then, so what is the fraction on the left? It's 1 over 1, 2, 3, 4, 5, 5. Here it's 1 over 1, 2, 3, 4, 5, 6, 6. So 1 over 5 is bigger than 1 over 6. Remember these signs? The mouth opens towards the bigger number. Bigger than, less than, equal to. Okay? Now let's do some practice problems. Compare the shaded parts, then circle the fraction that is greater. So here we have two triangles, and they're divided into equal parts. Yes, guys, these are equal parts. Now, which one of the shaded parts is bigger? Even though they're on different sides of the triangle, you can still tell that this shaded part I was about to call it a blob, is bigger than this shaded part right here. This blob is bigger than that blob. So we circle the one with the bigger shaded part because that's the bigger part of the whole, which is the bigger fraction. And this is 1 over 1, 2, 3, 4, 5, 6, 1 over 6, and this is 1 over 2. So 1 over 6 is less than 1 over 2. Here, though, we have what looks like the top shaded part being bigger than the bottom one. So we circle the one on the top. The one on the top seems to be 1, 2, 3, 4, 5, 6, 1 over 6, and the one on the bottom is 1, 2, 3, 4, 5, 6, 7, 8. 1 over 8, so 1 over 6 is bigger than 1 over 8. Now, we're going to compare more fractions, except instead of circling, we're just going to do the bottom part. The one with the less than or greater than signs. Oh. Okay. So when we write with the less than or greater than signs, usually we would write them with, well, numbers. Although technically, since, well, you can see over here that this fraction is bigger than this fraction, you could technically just write it like this. You could. But why not write it with the actual fraction? So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 parts. So 1/9 is smaller than 1, 2, 3, 1/3. What about this one? Well, it seems that the figure on the left is bigger than the figure on the right. You could just write it like this. But, again, why not actually find out the fraction? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1 over 12 is bigger than 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1 over 16. Now, by now, you may have realized something. The bigger the number on the bottom, if the numerator, the number on the top, stays the same, then the bigger the number on the bottom is, the smaller the fraction. I will go more in depth about this in higher grades. Now, let's move on to the next section. So apart from showing a fraction of a whole, you can also show a fraction of a group, with the group being the whole. So how many shapes are triangles in this group of shape? Well, we have one triangle. How many shapes are there? That's the total parts. So the triangle is the special part, and the total number of shapes is the total number of parts, which is 1, 2, 3, 4, 5, 6. The fraction of triangles in this group would be 1 over 6. Get that? Well, let's go on to the next bunch of example problems. How many squares are red? Well, we have one red square. And how many squares are there? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. You can also calculate that as 2 times 5 if you remembered your 5 times tables. So what is the fraction of red squares in this group of squares? It would be 1 over 10. If the fraction was, what is the fraction of not red squares or non-red squares, then it'd be 9 over 10. But it isn't, so we're just going to not talk about that. How many stars are yellow? There's 2 yellow stars. And how many stars are there in this group of stars? 1, 2, 3. 3 stars. So what is the fraction of yellow stars in this group of stars? So the yellow stars is the part, and the group of stars, the total number of stars, is the total number of parts. So that would be 2 over 3. And the last example of this section has circles and just shapes. So how many shapes in this group are circles? So there's one circle. And how many shapes are there in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 shapes in total. So the fraction of circles to all of these shapes in total, with the number on top being circles and the total number of shapes being the number on the bottom, that would be 1 over 12 as a fraction, or 1/12 being the fraction. Okay, so the next section is about a different type of group. Now these groups have equal parts. Let's circle them. So here's a group of 3, here's another group of 3, and here's another group of 3. There's 3 groups of 3, so there's 3 equal parts. So what fraction of the squares are blue? Well, in these 3 equal parts, 1 of the 3 equal parts are blue. So the fraction of blue squares in this group is 1 over 3. Yeah, now you may have realized that the fraction is also 3 over 9. So 3 over 9 is equal to 1 over 3. These are equivalent fractions. You'll be learning more about equivalent fractions after you've properly learned your multiplication tables in grade 3. Now let's circle some equal parts. And then we're going to write the fraction for the red part. Okay. So here we have what seems to be groups of 2. And there seems to be 9 of them. So that's the total number of parts. That would be 9 as the bottom number, the denominator. And how many red parts are there? So there's 1, 2, 3, 4. That's 4 over 9. So 4 parts out of 9 is red for this diagram. You may have also realized that this is also 8 over 18. 4 over 9 is equal to 8 over 18. Again, you will be learning more about equivalent fractions after you learn your times tables or multiplication tables properly in grade 3. Now question number 2 seems to have 4 equal parts, with 3 of them being red. So out of 4 total equal parts, 3 of them are red, and we get the fraction 3 over 4. Okay. So here, we're going to also circle equal parts, but instead of choosing the red one, write a fraction for the square part. So here we all have just individual, there's not really equal parts. The parts are individual shapes. And there's 5 of them. And only one of them is a square. We get 1 over 5. Here, however, it seems that we have 2 parts. Okay? That means that the denominator is going to be 2 because there's 2 total parts. And one of the 2 parts is made up of squares. So the fraction for the square part is 1 over 2. It is also, if you count each of the shapes individually, 4 over 8. Again, equivalent fractions, you will learn more about this after you've learned your times tables. Okay, so remember that you can take a break whenever you want. And here's the next section. So So for our last problem-solving strategy of the chapter, we get to choose our own strategy. We have the options between using a pattern, writing a number sentence, making a table, and just in general math. So let's choose a strategy and answer our questions. There were 10 dogs at the park. 4 of the dogs were puppies and the others were full-grown. Okay. What fractions of the dogs were puppies? So interestingly enough, we can't draw a picture, but we're just going to math this. So we have 4 dogs that are puppies and 10 dogs in total. This sounds like a fraction, and it is asking for a fraction. What fraction of the dogs were puppies? So since 4 of the dogs were puppies, then that would be the number on the top, the numerator. And the total number of dogs would be the number of dogs, well, the number on the bottom. 10. So it's 4 dogs, well, oh, puppies are dogs, over 10 dogs total. So 4 puppies over 10 dogs total. Now, I'm just going to show this in a picture, but if there's 4 out of 10 total, then you could technically just have 2 over 5. So the next sub-question, I guess, which is greater? The fraction of dogs that are puppies or the fraction of dogs that are full-grown? Explain. Well, since the fraction of dogs that are puppies is 4 over 10, the fraction of dogs that are full-grown would be the remainder, which is 6 over 10. So since the total number of dogs and puppies is the same, which means that the denominator is the same, usually you would compare numerators. So the number of full-grown dogs is actually greater because 6 is bigger than 4. Is greater because the number on the, let's make some more room for ourselves, top is greater and the number on the bottom is the same. Okay, here's the thing. The number on the bottom being the same is actually very important because sometimes the number on the top could be greater, but the number on the bottom is, well, different. And sometimes, even if the number on the top is greater, if the number on the bottom isn't the same, then it doesn't mean that the one with the greater number on the top, the greater numerator, is, well, bigger. Actually, usually it's, actually all the time, it's the number on the bottom that decides things. Okay, so, question number 2. There are 12 children at the park. 7 are on the playground and 5 are playing tag. Okay, let's math this now. So because there are 7 on the playground and there's 12 children in total, the fraction of children on the playground would be 7 over 12. And the fraction of children that are playing tag would be Since there's 5 children playing tag, 5 over 12. And really, that's it. Yeah, that's it for chapter 9. Don't forget to do your homework and practice problems, and I'll be seeing you next chapter, in chapter 10.